be a technical talk, okay? Hello, I'm Daniele from 20 Squares. We're an economics research firm, R&D firm, and we have worked in the Ethereum ecosystem for a long time. And today I want to tell you a bit about this very interesting piece of research we have worked on that was supported by the Ethereum Foundation. I mean, in general, last year we did a lot of research on Ethereum issuance. I mean, it was the talk of the town, right? Yeah, inflation. So this talk will be about, okay. Yeah, that part wasn't showing up. Okay, so this talk will be about, like, it will be an abridged version of a complete report we wrote. So my awesome colleague, Eric, who's here, has wrote a very long-winded blog post about the results of this research. And what's that about? Okay, so we used a stock and flow model. And if you don't know what stock and flow models are, don't worry, I will tell you in a bit, a simplified version, obviously, of the Ethereum staking dynamics, the staking flow. And we have looked at three big problems that are looming over Ethereum's future. Okay, one of these is runaway staking, so the tendency towards a scenario in which near 100% of the Ether are staked and the chain is very liquid. The second one, which is the thing that's most interesting for like most of the people that have been concerned with changes to the issuance curve, is excessive inflation or runaway inflation. And then also, I mean, this is like a thing that doesn't get talked about that much. I mean, in the context of Ethereum issuance, but governance centralization is a big problem that's related to that. And so by governance centralization, I don't mean physical centralization, so a small number of validators, actual validators, or like all the validators concentrated in a given geographical place. I mean a very small amount of economic entities that are holding all the staked ETH. Okay. But today we're gonna focus on the first one, runaway staking. I mean, the second one is kind of built in, but let's focus on runaway staking. Okay, so here's a graph of the Ethereum staking model. This is a stock and flow model. I will also give you the other parts, but this is pretty much accurate, actually. So what is a stock and flow model? Okay, it's so you can imagine these places, these circles, as tanks that are holding a liquid. And in this case, the liquid is all the Ether that was ever minted. And these arrows are just tubes between these tanks with one-way valves, so they only move in one direction, okay? So the tanks or the stocks here are, well, U is unstaked Ether, S is staked Ether, and O is the inaccessible portion of Ether. So either burned or slashed or lost the key. The flows here are, so here we have this F, which is reinvestment. Sorry. It's fees. Okay, so fees, and also MEV. You can include MEV in it if you want, but it's not important. So it's basically whatever validators get out of transaction fees. Q plus is new stake. Q minus is, well, unstaked ETH. And R is reinvestment of like validator rewards. Actually, this would be a bit more accurate if we had another smaller tank that's inside U. Let's call it V, which is the validator rewards, okay? And these B and J were just, so B, that goes from unstaked ETH to inaccessible ETH is just like EIP 1559 burn, okay? And J is lashing, okay? So all these things are subject to some constraints. Here's a nice table with the names and the domain and codomains. And as you can see, the V I told you about, the subset of U is here. And I mean, these are very reasonable constraints. I'm not going to explain all of them. Another important part is this is not a closed system, okay? Here, this dashed arrow, I, comes from nothing, okay? And this is the inflationary part of Ethereum. This is issuance, okay? It comes from the outside. It adds more liquid to the tanks. So these constraints are reasonable to have. Like, you can read them in the blog post, by the way. So let's just go through one, okay? So base fees plus priority fees, so are equal to the total fee, total fees that are paid for a transaction, have to be less than all the unstaked ETH. Otherwise, I mean, this wouldn't run. It's a very reasonable thing to assume, right? Be careful. All these flows are considered over moving averages over spot values at a given block. So in our research, we picked quarterly averages, but I mean, whatever's reasonable to you. Okay, so, well, okay. Some parts are not showing up in the slides. There should be dots over E, A, V, whatever, because these are differential equations, right? So, for example, let's read the first one, the first law that actually regulates the Ethereum staking model. Is that total Ether, okay, ever minted, the variation of that, there should be a dot, like a time derivative over the E, okay? The change in total Ether over time is just given by issuance. So as I was telling you, this is not a closed model, and this gives you like what gets added. Or, I mean, another reasonable one is the change in accessible ETH, so staked plus unstaked, is equals to, issuance minus burn minus slashing. These are very reasonable things to assume. One thing that could be added is actually stuff from EIP 7514, which actually poses an upper limit on churn rate. But the point of this research was also to look at like a case in which we don't have that, because this is an EIP that was introduced to mitigate some of the effects of very short-term runaway staking. We also make some more assumptions on this model. The first one is that like the yield out of issuance is sublinear, and this is important in order to avoid discouragement attacks. And if you don't know what discouragement attacks are, these are a very important and crucial point when talking about issuance, and I suggest you go and read Vitalik's paper on discouragement attacks. I mean, this is an actual elephant in the room. And also we assume that basically our moving averages do not differ a lot from spot values, which is another reasonable thing to assume. So how did we actually analyze the thing? Well, we built an open source library. Okay, you can go on GitHub and play with it. It's a wrapper around differential equation solvers, because these things are dynamical systems. And it's specifically built for this kind of macroeconomic analysis of Ethereum. Okay, and I mean, myself and my colleagues at 20 Squares firmly believe this is the way to approach issuance research and in general macroeconomics research in Ethereum. It shouldn't be, Ethereum economics shouldn't be vibe-based, okay? we actually need to look into the actual effects of stuff with like in a precise and scientific manner before pushing, I don't know, croissant issuance, okay, or deflationary ETH. So please go and play with this, learn about this stuff. It's important. So from our research, we have like figured out some very important way to go about issuance. Okay, so if you keep medium reinvestment rate, low inflation, okay, it has to be positive but low, and even lower fees, then it's more likely, okay, that we will converge to a future that's in which we don't have non-super long horizon runaway staking. Okay, we will see that, like, we can push the problem down the line, but it's like the problem is kind of baked in. So, why low inflation, though? Okay, so in the case of strong deflation, so this is for all of you who care about your bags and want to reduce Ethereum issuance because this will appreciate your bags. I mean, in this case, like in the case of strong deflation, in which you have like more deflation than the reinvestment rate, this is very unstable. That gives you a very unstable dynamical system. And in the case of zero or very weak deflation, so still not positive, okay, then the tendency towards runaway staking can be moderated only by either high churn rate or slashing, which is undesirable. I mean, we don't want validators to be slashed. So, in short, okay, runaway staking that's not super long-term can be avoided only while inflation is held at the same time low enough that concerns over inflation obviously do not dominate their investment rate, and at the same time high enough not to be dominated by their investment of priority fees. So it has to be like low but not too low. So here's the important question, though. I'm sure you're all here for this. So should we reduce inflation? The short answer is no. No, this is very delicate, okay? I mean, before thorough investigation, which, by the way, this research was part of, we should like do more research on this kind of topics, because this is what keeps Ethereum running, right? The economics. We shouldn't touch this stuff. Okay, we shouldn't push for strong deflationary ETH or croissant issuance or whatever without first having a thorough look into it. Okay, but Daniele, I really care about my bags. Maybe we can decrease inflation issuance and we will have the magic EIP 7514 that poses limits on the churn rate. Save us. Well, not really, actually. Okay, so and yeah, so the problem is that this is designed to tackle the problem of runaway staking only on over very short time horizons. So spikes of either mass exit or mass entering in the validator set. And in general, as I was telling you earlier, near 100% staking is kind of like baked in, okay, for our current understanding of issuance, in which we have a static issuance curve. So, but if you're interested, I mean, the repo is open. There's also the notebooks we used for doing our analysis, and I suggest you go and play with it or play with whatever else, like way you have to model Ethereum macroeconomics, and play with the constants in EIP 7514. Maybe something will come out of it. Personally, I have some ideas around how to tackle this problem. with dynamically adjusted curves, so not a static curve. We will see. If you're interested, come to talk with me about this. So, the talk is over. Thank you for coming. And yeah, feel free to ask any question.
Thank you very much. Do you have any question? Oh, I am come. Sorry.
Yeah. When you say that 100% ETH will be staked long term, maybe it's best to explain what you mean by that. Like, what does that mean in who would be staking it? Why does, or who are the big players, maybe? Why don't you tell us about that?
I mean, this is very difficult to decouple from very strong economic centralization, right? So there will be a very small number of large economic players that have all this ETH in stake. I mean, 100% ETH staked is a very catastrophic scenario, but like near 100% is a future we're actually starting to get accustomed to, right? So, for example, think about the L2-centric future that is being pushed on like the public opinion over Ethereum. So the idea is, okay, a lot of ETH is staked, the chain is very liquid, and what's like the very little liquidity we have left over is used to settle for L2s, okay? For example, blob prices or whatever, like roll-up.
Thank you for the questions. Yes, welcome.
Hi. So the longer I'm working or looking at like the whole crypto, I see more and more parallels to the traditional finance. So how much of your analysis can be traced back to the traditional finance, or did you, how do you compare those two if you are looking in like inflation and all those?
Yeah, I mean, obviously, dynamical systems modeling is widespread in finance, like traditional finance. Obviously, the staking model is totally different because, I mean, the whole, from one point of view, we're looking at like the intersection of the interesting problems that we're looking at is very thin, okay? We care about inflation, but also we care about all these other problems which would kill Ethereum, right? So there's some overlap, but it's very little because you have to change stuff around to accommodate like research about Ethereum, like the whole model. I mean, blockchain is a whole different thing from TradFi, even economically and technically. So that's.
Thank you.
Thank you very much.
I guess first off, awesome talk. Thank you.
Thank you.
I guess in theory, my question would be around if more and more Ethereum goes into staking, my assumption would be that yields would need to come down, which would make it kind of less, people would be less motivated to stake at that level. Is this something that you're seeing in your data? Or
can you raise your voice?
Oh, sure. Sorry about that.
Don't worry.
As staking nears like 100%, my assumption would be that yields would need to come down.
Yes.
Which would push people out of it.
But even looking at the yield curve, this is not like discouraged by over long time horizons. Okay, we're talking about.
Yeah. So from what you're seeing, like you actually don't think the yield curve would come down enough to demotivate people from moving out of staking?
I mean, the current yield curve, no. I mean, this. See, like reducing issuance doesn't solve it either. So this is the important part. I mean, this comes from the actual simulations. Yes.
All right. Thank you. I'm very grateful for your work.
Thank you.
Thank you. Now we can finish the presentation, and we will back at 1 p.m. Thank you.